I'd like to now hand it off to Chris Kemp, the CEO and co-founder of Astra. From being the first CTO of NASA Ames, he has had a remarkable journey within the space industry, and he would love to share a few words about his journey and the company. Thank you.
Cool. Hey, everybody. Good to be here. What I really am excited about is just being here where you guys do so much stuff. You build hardware. I think you guys were founded, I think, back in the 1950s. Since then, I think you guys have done about 24 rockets. You guys have done like over 100 satellites. I think the coolest satellite ever, just coming back from Burning Man, in 1992, you guys did the Ultraviolet Explorer satellite and determined that the universe actually glows in ultraviolet light. I love things that glow in ultraviolet light, so saw a lot of that last week. This is something that really makes Astra Astra. So we started out in a garage in San Francisco, and we build hardware, just like you guys do. And the hardware, one thing led to another thing, and the more you build, the more you learn. Because you can do a lot of analysis and design stuff, but until you actually build hardware, you can't calibrate the analysis and the designs and make real progress. A lot of what you do just doesn't map to what you thought it would do. And so until you actually build hardware and test hardware, you're just not going to move very quickly. So I think what we're starting to see in the space industry is two very different approaches to innovation. An approach where I call it like the Blue Origin NASA approach, where you spend tens of billions of dollars, and in 20 or 30 years, you build a rocket and it works the first time. And this is super important if what you're trying to optimize for is it works the first time. And for a program run by a nation state or a billionaire that doesn't want to have a rocket blow up, this is prudent, but it does take decades and cost tens of billions of dollars for you to do the analysis and the testing leading up to the event where you get a success the first time. Very impressive, very expensive. Obviously, that wasn't the path we chose. It's not the path SpaceX chooses after 10 Starships are, in a very exciting fashion, dismantling themselves on their way to orbit. But they're learning very quickly, right? And so anyway, I think that's kind of where I'll start this. Back in late 2016, early 2017, we were in a garage in Soma that was about 1,200 square feet. And this is Dr. Adam London. He is the brains of the operation. He did his undergrad, master's, and PhD at not Berkeley, but at MIT, where he was very focused on very theoretical things. Like he built a rocket engine that was the size of your thumbnail, that was literally photolithographically etched on a silicon wafer, and all the valves internally were MEMS. And if you took thousands of these little things and glued them together, you'd have like a Star Wars-like engine. Where you have a hypothetically very efficient engine, but you built them in the lab, and they kept exploding because apparently silicon is a pretty, dusty thing to work with when you start to apply pressure to it and things like that. So, Adam and I teamed up, and the first thing I asked Adam was, well, like, how do we make this less theoretical? Like making really small rockets is one thing, but is there a business case that is different than, say, a rocket lab, because they were well underway, SpaceX well underway? Is there something different that we can do? And so the big idea that we had in this garage was, well, what if you just make thousands of rockets? It was actually another academic paper you can find still on the web today on the Fermilab website called "A Rocket a Day Makes High Cost Go Away." And it was written back in, I think, 1992 as well, when you guys did that cool ultraviolet satellite. And the thesis was that the reason why rockets are so expensive is because you don't make many of them, right? And so all of your fixed costs are amortized over a relatively small number of vehicles. And so this drives towards a thinking around, well, if you're going to make a small number of something, you better make it reusable, because why throw away an airplane every time you fly it? It sounds pretty logical. So this kind of drove this idea around the rockets must be reusable, and rockets must be very large as well, because if you're going to maximize the amount of payload you're trying to reach to orbit, the mass fraction of the rocket needs to be as large as possible. And so you've got this school of thought around, well, let's just make the largest rocket ever and make it reusable, which is the SpaceX approach, and I think the industry is going to. So our approach was always the opposite of that. It's, if you take a soda can, soda cans, I think we make about 1 billion of them every day out of aluminum. Aluminum is basically free. And if you can figure out a way to take aluminum and turn it into, a rocket's basically a big cylinder with some domes on it and an engine. And if you look at an engine, a rocket engine in some ways is simpler than an internal combustion engine. It doesn't have a bunch of pistons and moving parts and magnetos, and it's just a combustion chamber. If you, depending on the engine cycle, you can actually tap off the combustion gases into a turbine. You have a single turbine that can turn 2 pumps. It actually has fewer moving parts by a significant margin than an internal combustion engine. So you can get back to the, well, if you just build a lot of them, maybe the cost can come down. And so the basic idea in that garage was, let's do the math. Let's just look at what the BOM cost of a rocket would be if you made 500 of them, as suggested by this paper, A Rocket a Day Makes High Cost Go Away. And so that's how things got started. So about a year and a half after we founded the company, that picture was taken. That was not generated by AI. What's super cool about this picture, among other things, there's a rocket firing with the Salesforce tower behind it, but gives you the timestamp. This little area right here is where they filmed The Matrix. That little black thing, that's the highway scene where they were kind of jumping around between cars and things like that. And you can still see, I think they finally put dirt on top of this, but there was, you could see from satellite images the soot on the asphalt that we charred there. That was rocket 1. Actually, that's rocket 2.0. Anyway, so that whole system we could transport out to the airfield and test about a mile from our office. And this is all about 5 miles from here, just to give you a sense of what's going on in your backyard. We timestamp pretty quickly after that demonstrated that we could build an orbital vehicle. And that image was taken on December 15th of 2020. Again, the company was founded more or less January of 2017 is when we actually got going. So the business was incorporated on October 1st, 2016. So pretty quickly, putting that back in the kind of framework of other companies, we basically did this in just over 4 years. Falcon 1 at SpaceX took about 8, 7.5, and then other companies. So how do we do this quickly? There was a movie about it. We were not afraid to build rockets and test them, just like SpaceX is doing the Starships. Like the more you're able to build hardware, collect data, and iterate on the design, the better. And so this led to a mistake. That's fun. So yeah, so this was 2021. The next year we got to orbit and we're like, wow, this is great. Let's go public. Virgin Orbit had gone public. Rocket Lab was going public. Planet was going public. A huge amount of capital in capital markets had been moved into these things called SPACs. I didn't know what a SPAC was, but it sounded, like we've got to raise some money. The thesis of the business was we've got to build a rocket factory, right? We're not building a rocket, we're building 1,000 rockets. So I need to raise a bunch of money to build a rocket factory because that's the whole point of the company. So let's go public. And anyway, that was the day that the stock traded at its highest value. The next day it was lower. We would launch a rocket, it would work, it would go lower, the rocket would blow up, it would go lower. Nothing we did, no sale we announced, basically every piece of news that came out of this company, the stock went lower. And that got to the point where, it just didn't work out, but I'll get to that in a second. What we were able to do is we were able to take the $500 million we raised in that public offering to go build the factory that we needed to mass produce the rocket. And that was key. So this is a building which the only thing that we painted since 1983 was the black little front of it. So every dollar, every wall socket, every Ethernet port, every workbench in this building was purchased, and literally it was a shell of a building with lead paint just falling off the ceiling. We literally turned every penny into the means of production to build a rocket a day. And so that kind of looks like that now. It took a bit of time to build that out, like 2 years. But if you drive down the street, you can actually see a larger than SpaceX Hawthorne facility manufacturing plant that can actually churn out 2 rocket stages per day with one more of these little, you need 2 of these to do that. It's about $1 million. Here's a little fly through, it's kind of fun. And that's the rocket production line there. So we basically take a coil of aluminum that costs about $20,000 that can make 3 rockets. We uncoil it, we flatten it, we laser cut it, we recoil it, we friction stir weld it, and then there's a circumferential welder that builds the cylinders of the rocket. So the whole concept is you put in aluminum on one side of the building, and then rockets come out of the other side of the building. And there's Rocket 4, most of the mechanisms, engines, valves, all the electronics, all the software, it's all made in that building. So this is kind of like a gigafactory to Tesla is a rocket factory to Astra. And so you could put more rocket factories in other places, and you could make rockets in a lot of places. Why do you make rockets? You don't make rockets because they're fun, they are fun, but you make rockets because they're delivery trucks to space. And so if you're going public and you're raising billions of dollars, then you need a business plan, which is not just we're going to make delivery trucks. Just like SpaceX is currently valued at $400 billion because of Starlink, like we wanted to have a satellite that would justify all the rockets we were planning on building so we could build a vertically integrated space platform. I'm not going to get too deep into that, but it's a whole interesting topic. First thing we did was we bought a Hall effect thruster company, because to build a satellite, you need like 4 things. You need propulsion, you need payload, typically a phased array antenna, optical interconnects. You need a solar array, and then you basically need the, what am I missing? The bus itself. So this was a key element of the efficiency of the constellation. So we went shopping, and we found the most efficient engine, because if we're going to have a small rocket, you need to get the most bang for the buck out of these satellites, because the satellites are going to be smaller than what you might launch on a Starship. So we found this company down in Mountain View, led by a guy named Mike Cassidy, super efficient engine, has like 1,400 seconds of ISP, perfect for putting about a 500-kilogram satellite in orbit and keeping it there for about 5 years, powered by Krypton or Argon. It had never worked yet, but we paid $150 million for the company because, hey, we just raised a bunch of money. This business actually kept Astra alive for the past few years. So when things got crazy, we were working on this rocket, and we had bought this spacecraft engine business. And then as we were trying to make that work, things went a little sideways. And I think we lost about $1 billion that day. I looked at that and I'm like, it's annoying. So at that point, things got a little, but we were working on this rocket, and the rocket was very important. I decided, let's sell the satellite engines. So let's see if we could, because the engines had started to work. We had this big SDA constellation going up. We sold hundreds of these satellite engines for about $500,000 a piece. So we had about $100 million of orders for satellite engines. And as a public company, this is revenue. This is good. Let's see if that'll work. It didn't work. Basically, there was a point in that journey where the market cap of the company was like $50 million or something like that. And so obviously, I'm the worst public company CEO ever. So I met with the board, called a little board meeting. I'm the chairman, so all my fault, obviously. I said, OK, board, you should fire me because this is just totally not working out, or you should sell the company. And I want to help you do whatever you can do for our shareholders that have invested in this company, like whatever the best outcome is for them. We should totally do that. And I'm going to fully empower you as the independent members of the board to figure this out. You should hire new investment bankers. You should hire new advisors, because obviously the ones that I've hired are crap. Here's an offer to buy the company, which was a bit of an interesting board meeting. I also told them that they could fire me, but I couldn't fire them. So they were totally independent and safe for me, even though I had a lot of power over the situation. But they should go and do that. So I helped them attempt to find a buyer for Astra. And what happened there, this is about 2022, 2023, Virgin Orbit went bankrupt. And no one bought them. No one even bought their assets. And so we're out there trying to sell Astra to Rocket Lab, to everybody. But no one wanted to buy it because, you have Richard Branson's thing where you have a 747 drop in a rocket and you just get knighted. If they're not buying that, why would you buy Astra, right? And so we literally could not find a buyer other than me and Adam for this company that was once valued at billions of dollars. And so we bought the company back from shareholders so we could finish what we started. The lesson there is if you've got a team of people and you are working on something important and you have customers and you have a bunch of engineers and employees that are not giving up on you, well, don't give up on them, right? Don't give up on your customers. Don't give up on your employees, whether you're public or private or what the thing is. These are all, name one satellite company that hasn't gone bankrupt. Name one airline that hasn't gone bankrupt about 3 times. You won't find one. So in this industry, this is really hard stuff. And if you're a leader or if you're involved in a company, just see it through, right? The thing that matters is this rocket began its life 5 years ago with a tremendous amount of hard-fought lessons learned from rockets that flew sideways, rockets that did all sorts of things. If you can keep that together, That's the only way to succeed. Look at SpaceX. You know, it took them a failed flight, rocket, the third Falcon 1 flight. Elon had literally, he was broke. Like he literally borrowed money from his friends to get that across the line. And if he had not done that, SpaceX wouldn't be. And it was ultimately NASA, while I was there, that gave him $500 million that he loaned to Tesla that saved Tesla. So the lesson here is just don't give up on this stuff because it's hard. So that's, you know, the other lesson is product market fit's a bitch. So we thought in 2017 that satellites would largely be like Planet Labs' Dove satellites. The dominant form factor for satellites moved from these CubeSats to 500-kilogram communication satellites. So if you're building a rocket and you're seeing thousands of Kuiper satellites and SDA satellites and Telesat satellites and IRIS², you go look at what's out there. That little rocket was too small, and so is Electron. And so the problem is if you can only throw a few hundred kilograms, your TAM, your addressable market, is basically insignificant, right? So it costs the same-ish to build the small thing as the big thing. So just build the thing that addresses the market. The problem is when you're talking about a rocket, that's a complete redesign. You literally have to start over. There is almost not a single part, maybe the video camera, that isn't, you know, every valve is sized differently. Every run line is sized differently. The entire arc, you know, you basically have to, from systems engineering perspective, you have to literally start from scratch. It's a do-over. And so all you take with you is the lessons you've learned and the experience you have making all the mistakes you made to get you there. So anyway, that's what we've been up to. I want to take one thing that we did from the very beginning that I really liked was why do we need to exist, right? There's plenty of rockets out there. Eric Schmidt just took over relativity. That's cool. Rockets are hard. He'll figure that out. But like he's going to go build a rocket that is twice as big as Falcon 9. Okay? So you've got Blue Origin. You've got the Starship. You've got Relativity. You've got Ariane 6. You've got Vulcan. Lots of big, and you've got Neutron. Lots of big rockets out there. Lots of big reusable rockets out there. What we haven't seen is we have not seen a completely mobile tactical rocket. So what if, here's a big idea. What if you could put a dozen drones in that rocket? What if you could go put those rockets anywhere in hundreds of locations? I just saw yesterday the Lockheed Martin Missiles and Defense Group got a $9.8 billion order for 1,780 Patriot missiles over the next 2 years. Okay, Patriot missiles are used when you have like Houthis lobbying things into Israel and you need to like intercept things. They're 10-inch diameter, 16-foot long, solid rocket missiles, basically, for $4.7 million a piece. They just sold those. $10 billion contract, Patriot missiles. So Patriot missiles, that's a $100 billion program. There are about 1,400 Patriot missile launchers organized in batteries of 4 to 8 launchers in about 130 locations in 18 different countries. Why do I know this? I think it's interesting. Because if there are Patriot missile systems in 18 different countries, how many space agencies exist in the world? 100. How many sovereign nations can actually get to orbit? 6. So there's a total addressable market of like 75 space agencies that would love to be able to get to space. How are they going to do it? China, India, or Astra? This is the way you do it, because I can pack these rockets up and the spaceport into shipping containers, and I can send it. We have a DoD contract already to do the first launch out of Australia, the UK. You know, every European attempt to build a small rocket has, up until this point, failed. There is a global market to, just like in the early part of the last century, use American aerospace technology to transform the aviation industry. We can transform the space industry, but you're not going to do it with the Starship, right? Because the international airport starts out as a dirt airstrip. You know, when you land at the Oakland airport down the street, this is where Amelia Earhart landed. There's an old building there. You know, you take a small airplane and you land it on a dirt airfield. We can launch this rocket from a dirt strip. The last launch that we did out of Cape Canaveral, which they told us it would take 2 years to do, it took us 6 months. First Part 450 license was done on a launch pad that did not have electricity. So we showed up with our containers. we set up, and we did a launch in 6 days. From arriving at the site without electricity, and we had a network connection. Now we don't need it because there's Starlink. So we could literally go and airlift this system onto an island and launch it. I like to joke we could do it from a Walmart parking lot. Walmart doesn't like that. But, I mean, you don't want to crash on a Walmart. But the idea is if you could put these portable mobile spaceports in a dozen countries, if you could have millions or thousands or hundreds of thousands of Anduril drones in thousands of rockets, in shipping containers, in hundreds of locations in dozens of countries, why the hell do you need 850 military bases all around the world that cost the better part of $1 trillion to operate? If you look at the $1 trillion defense budget, about $800 billion is O&M, which is code for that's what we pay to run the machine. It's not hardware. It's just we are spending $800 billion of your money every year to operate hundreds of military bases all around the world. So a bunch of Navy SEALs can put a bunch of drones next to a border that can fly to do a mission. Rockets, AI, and drones are the future of defense, full stop. And so if you can put drones in rockets, and you can put rockets anywhere, why would you, like right now we have a defense posture of if space is so important, if GPS is so important, if communications and Earth observation is so important, who cares if you have thousands of satellites if you only have 2 spaceports? The adversary just has to take out 2 locations, and they shut America out of space. That is a vulnerability which will actually create a war. But if the adversary knows that you can replace any satellite from anywhere, it's actually the most powerful deterrent for World War III ever. So if you go back to the thesis around the whole arms race with the Soviet Union, there is a new arms race, and it's about rockets, AI, and drones. And whoever can have a more resilient infrastructure in space, if you can achieve that, you can achieve peace. Because you basically become impossible to attack. You can't disable what you can't see. So our rockets will always fit in shipping containers. Our spaceports will always fit in shipping containers, and we'll put little Walmart logos on them and Amazon logos. And so you don't know whether it's the Amazon delivery truck. You don't know whether it's an Amazon distribution center or a rocket factory. Because what's going on is, in space, what do you see? So there's a future here where this kind of stuff is becoming increasingly important. There's our rocket being loaded into a C-130. We've only ever launched this way. This isn't hypothetical. Every time we've ever launched, we've done a hot fire test here in California, and then we've shipped the system to wherever it's launched from. Cool, okay. Other things going on. So yesterday, Al Weston's here, one of my heroes. I have the opportunity to work with him now. Can't say enough about Al. Al and I worked together at NASA Ames. He ran all the programs. He discovered water ice on the moon, crashed the spacecraft, bombed the moon, worked on a bunch of missile defense stuff, made a lot of things that went boom. Generally, the Aegis interceptors that are protecting us from things that are attacking our bases was his program at the DoD. Kind of cool. But this is his engine. So we have a new rocket engine. There was a company called Firefly. They went public. And we bought the engine from them, and it was garbage. So we literally couldn't get the same engine twice from them, and none of them matched the CAD. And if you're in engineering, you know that just doesn't work. So we had to basically start from scratch with this engine. So we built a completely new combustion chamber out of a new copper alloy called GR-COP. And yesterday, that engine fired for the first time. And we are planning on trying to fire it again here in the next few days. Super cool engine. It's, I believe, the largest 3D printed engine. It's printed in 2 parts. It uses some of the heritage we developed around welding the engine. So it's basically printed inside of itself in a printer bed, and then it's welded together, so it stands about that tall. and it's a super cool engine. And we're going to have 2 of these powering Rocket 4, producing just under 50,000 pounds of thrust. So we'll be able to throw about a ton to orbit with the new rocket. So a little bit bigger, a lot more payload capacity. 100 times the payload volume, at least 10 times the payload capacity. Here is a video, because rocket engines are cool to watch. Wait for it. Would you turn down the brightness? Anyway, they're cool. This is actually kind of cool. So this is what's happening literally right down the street from you guys. We have 2 indoor rocket engine test cells where we did thousands of tests. This is actually this test is occurring at our Castle test site, which is about an hour and a half from here, because this engine would disturb the neighbors, especially if it didn't work. But so this is using a tap-off cycle based on Ukrainian IP. We take the gases from the combustion chamber, we duct them into the turbine, and we have a single turbine that turns the fuel pump and the LOX pump. So basically, once this engine is running, it stays running because the combustion gases are what's powering the turbine, and it's a very simple, inexpensive engine to build versus other engines that effectively have multiple rocket engines that power the turbines. A lot more valves, a lot more complexity. So we've really tried to figure out what is the simplest engine on the simplest rocket that you can mass produce. There's a lot of cool software stuff happening, but I'm going to run out of time. And this is a cool video. It's like, oh, you didn't. This is the dark music. This is the Trump music. So with that, the reason why I'm here is because you should all come work for Astra. We're literally like 10 minutes from here. We have an incredible team. It's a startup again. And one of the things that I really enjoyed working on with Al is just ripping out all of the overhead that we took on as a company, as a public company, all the financial systems and compliance stuff, and just getting it down to this like really beautiful core. And so we're focused on how do we make engineers productive? How do we increase the velocity of the team? How do we increase the rate of learning on these teams? And so it's great to see all the different teams working on avionics, working on the stages, working on the engines. And we had about 25 interns this last summer. So if you're enrolled here and you want to like come do some part-time stuff, just go to this website. There's an application for a new graduate or a graduate position. Just apply to that, and we'd love to have you. And it's one of the most fun. It's more fun than SpaceX because we're not on the border of Mexico where they'll chop your head off if you accidentally take a left turn, and you don't have to live in a trailer, and we don't make you work 6.5 days a week, 12 hours a day. It's appreciated if you do, but it is not required. So with that, I will wrap. Thank you all.
We would like to thank Chris Kemp for being our keynote speech, and we are going to open the floor for a quick Q&A. So if you guys have any questions, please raise your hand.
I love questions.
Yeah.
Yes, go ahead.
Yeah, hi. My name is Rama Fulon, the founder and CEO of... Can you use the mic? Oh, sure. Thank you. Hi, Chris. Thank you so much for that presentation. My name is Rama Fulo. I'm the founder and CEO of a company called Satellite, S-A-T-L-O-I-T. You spoke about software, and you said that there wasn't enough time to go into that. Like, I'd love to hear a little bit more about what the software angle is from the new Astra.
So yeah, very early on, we realized that data was important, and so we have a platform that I'm super excited to leverage. Where whenever we do a test, we can actually take every sensor that's recorded every bit of data from any test in the entire history of the company. We have all that data. We don't use LabVIEW because that's like a toy. We take the data from the data acquisition devices, which sometimes are made by National Instruments, but don't have to be. And it gets queued up onto a controller running a platform that we've built. It gets streamed up into AWS GovCloud. And then there's a massive data lake. So I can take all the data from, for example, all these launches, and I can take every sensor from every vehicle, and I can overlay them, and I can see patterns. This was actually super cool 5 years ago, but what's even cooler now is that you can use AI to tag the data, and you can find patterns and anomalies. And so we're in the process of building a GPU cluster right now. Most everything we've done has been published in a wiki. If it's knowledge, and if it's an action, it's in Jira. So this Confluence Jira suite of tools from Atlassian literally contains the sum knowledge of every employee that's ever worked at Astra. And so we're going to train a model on all this information to effectively create Jarvis. So like imagine if every requirement, if every document from every supplier, everything that we've ever learned, every employee that's ever worked at Astra, were available to every employee that does work at Astra. And then you can ask it questions, and you can have it effectively cross-correlate these things on a model. So I think that's the short answer. Thank you. Yep.
Next question up here in front.
Hi. You mentioned earlier that you're working with Anduril. Anduril is a defense company. They're kind of like a tech company.
Yeah.
So I think of them as like the Silicon Valley of like defense.
Yeah.
In terms of like loading Astra's rockets with Anduril drones and having them fly anywhere around, you're saying that it's a huge possibility that this is the new deterrent for World War III.
Yeah.
And having that deployability and having that action. So in terms of like deployability and reliability, where does Astra stand on that?
Well, I think the Defense Department understands how important this capability is. So they've been embedded at Astra throughout the development of Rocket 4 to certify this as what's called a Category 2 capable vehicle. And so there's an enormous amount of, there's a real shift. Rocket 3 was the kind of cowboy rocket. Rocket 4 is the, okay, we know we can do this, let's do it right. And right is, it's not the $20 billion 20-year journey, but it's also not the, let's just throw it together and see if it works and not document it and not have. So there was a huge effort while we've been quiet to do a fairly comprehensive suite of failure mode effects analysis, systems engineering, test coverage analysis. So what's been happening at Astra is every single weld has been pulled 100 times so that we know exactly what the manufacturing process is for everything that goes into the vehicle. Because that'll pay dividends when you can knock these things out on a production line because you can automate the stuff. So we literally deployed hundreds of millions of dollars in a factory and hundreds of millions of dollars in an effort over many years to do the systems engineering and the work to make Rocket 4 something that can be mass produced at scale. The big idea was if you're going to launch a rocket every day, 1%, 99% reliability, like space shuttle reliability, not good enough, right? Because if you lose a rocket 2 or 3 times a year, are you going to really be able to fly every day? So the big idea was actually you can't get to scale without reliability.
Next question over there.
Hi, Chris. Right over here in the 4th row.
There you are.
Yeah. My name is Abhi Kumar. I teach the NewSpace Economy course here at UC Berkeley.
Cool.
In a previous life, I was also leading the partnership between Planet and Astra for a few months when I was at Planet. 2-part question. Question number 1, and this might be 5 years before I should be asking this, but since I have you in the room. If and when you choose to go public again, what would you do differently this time? That's the question number 1.
Yep.
And question number 2, what you just described about Rocket Force, capability being deployed in different geographically disparate locations. sounds like almost like a tactically responsive launch capabilities, right? What bottlenecks or what roadblocks do you see, especially from a geopolitical standpoint, for that vision to actualize?
I want to take the second question first because it's just more fun. I think with this administration, it's just a question of like, can we send the right 24-karat gold-plated trophy situations to the right people? Because I think this administration really wants to deregulate everything, right? I think this administration might be the administration that makes America less protectionist in space, right? That abolishes aspects of ITAR, CFIUS, that are impediments to seeing American space technology proliferate globally. And so say what you will of the rest of the policy stuff, but that's, that is not a bad thing. Because otherwise we're just going to see China and India just dominate global space. And that's probably not good for America. So that's the second answer. The first answer is, I think being a private company is great. Having all of my time focused on the business is great. As a public CEO, you have to focus a lot of energy on what's happening this quarter and what the analysts think of you and a lot of compliance stuff. You've got a board that's entirely independent from you that you're having to manage. Being actually running a business is a different thing, running a public than running a public business. If you have to be public, the one observation I would have, the reason why American manufacturing is just, screwed is because American public companies don't manufacture anything. They integrate. If you look at a Boeing or a Lockheed or a Northrop Grumman, they don't have machine shops there, right? They're buying parts from a bunch of private mom and pop companies that have no ability to scale. And so that was never our playbook. Our playbook was you go to Astra and there are 20-foot bars of aluminum on shelves and racks, and there's a saw house, and we saw them into pieces, and we bring them in, and we have CNC machines, and we machine the things. That's important for development because if you're trying to go fast, you don't want to wait for a part. If you go to any machine shop and you say, hey, I need this part, I need one of them, good luck. Okay? So if they work for you and you say, I need this, our entire machine shop is working all weekend this weekend. Why? Because I asked them to. Right? You can't do that if you don't control the company, right? Or you pay a lot for it and then the costs go up. So if the real problem is that if you're a public company and you have PricewaterhouseCoopers or whatever come in to audit you, and they start asking questions like, where's the oil that goes in the saw blade accounted for? That's annoying, but it's also expensive. And it means that you have a large finance organization and you have a large, you're paying $5 to $6 million a year for PwC to dig through all this stuff. So running a manufacturing organization with all of the detail and complexity of cost accounting and the accounting that goes on of all of these things, is expensive. And so what I would say is it's not impossible, but it's a huge hit to margin. And so I would say we'd need $1 billion of revenue at 30 to 40% margin before I'd even consider it, right? Because otherwise it's just too much of a tax on margin. It's like a rocket. I like to equate companies to rockets. If a rocket has too much mass, it just doesn't reach orbit, or you have no payload. So I would say a company is the same thing. Like if your company does not have enough thrust, like enough revenue, enough growth, then it will literally never reach critical mass and it will not be able to stay a public company. It will not reach orbit, it will never get there. And that's really fundamentally what a lot of companies, that's the mistake a lot of companies made. They underappreciated the cost and the overhead and the friction associated with being public, and unless you print money, a lot of tech companies that are just very high margin software businesses can grow that quickly because you can grow revenue that quickly and margin that quickly. But a manufacturing business where you're having to scale CapEx and hardware, it's extremely hard to be, it's hard to be a small public manufacturing business.
Thank you.
So I would be a large public manufacturing business. That's right. Cool.
Last question. If you could come up.
Hello. I had a quick question, sort of a follow-up about your new approach in terms of launching from different geographical areas. How is Astra kind of going to find the balance between giving your potential clients, who may be nation states, giving them as much flexibility in terms of launching how they want to, and kind of also finding the balance between, hey, you're not giving up too much and they're not able to back engineer it. So how does that balance between knowledge transfer and export restrictions kind of Like, what's your ideal view on that?
I mean, even a spaceport is considered ITAR, right? You know, because it's where the QD interfaces with the rocket, that's IP. So if you really want to respect ITAR, just put the entire thing in shipping containers, show up on a dirt pad, and take it with you when you're done. There isn't another rocket system that can be deployed that way. It's how the Patriot missiles are protected. Like literally, you can just have someone that works for the DoD with the thing and don't have them leave and put cameras with AI on it and just make sure that your IP is protected. That's the answer. Like, no other system can be deployed this way, which is why the launches are being done in the Five Eyes, which is our most strategic intelligence partners first. But beyond that, I think this is the ticket, like to see American space technology really proliferate around the world. Good. With that, such a pleasure. Thank you. Thank you. Oh, love. Thank you. Oh, wow, this is great. Amazing. Thank you all so much. Such an honor. Appreciate it.